Hello, I'm making this video just so you get some useful factoring tips before you start Unit 16. We haven't done factoring for a while, and so I just want to make sure that we review on some of the factoring that we did last quarter before you start Unit 16. The first factoring method that we talked about was factoring out a GCF. So let's go ahead and take a look at a couple of examples with this one. One example could look something like this: 9x plus 54. If I look at this, I try to find the greatest common factor that can factor out of both of the terms. So our greatest common factor for this one would be 9. And then what we have left is x plus 6. So that's an example of factoring out a GCF. Another example you could use this method is you could have a trinomial. So if I look at something like this, 4x squared plus 20x plus 100. Again, we're trying to find the greatest common factor that can come out of each one of these terms. So that would be 4. And then what you would have left is x squared plus 5x plus 25. So these two examples are examples of factoring out a GCF. Another method that we used in factoring that we learned was factoring trinomials. We had a method that I used called the Kim trick. So let's go ahead and look at an example where we can use this method. The Kim trick can only be used with a trinomial. If you're not a trinomial, then you can't use the Kim trick. So the first step in the Kim trick is taking the leading coefficient and multiplying it by the last term. In this example, the leading coefficient is 1, so if I multiply the last term by that, I still get the same thing. So no need to do that in this example. The next step in the Kim trick is you're trying to think of two numbers. When you multiply, you get the last term, and the same two numbers when you add, you get the middle term. So thinking for that, that would give me -5 and +3. -5 times +3 is -15. -5 plus 3 gives me -2. So to write this out, it would be x minus 5 times x plus 3. And then the last step in the Kim trick is you would take your leading coefficient and divide each one of these by that number and then reduce it. Since the leading coefficient this time was only 1, if I divide each one of these by 1, I would still get the same thing, and so the Kim trick is complete. So these are the factors for x squared minus 2x minus 15. Let's go ahead and take another look at another example where you have a leading coefficient other than 1. So 3x squared plus 7x minus 20. So now your leading coefficient is 3. So let's go ahead and try using the Kim trick for this. So I take my leading coefficient and multiply it by the last term. Since the leading coefficient is in this term now, we don't have to write it down. So we would just write it down as x squared plus the middle term stays the same minus 60. So again, we're trying to think of two numbers. When you multiply together, you get -60. And the same two numbers, when you add together, you get a +7. So this one might be a little bit more difficult because this is a bigger number and you have more combinations to get to 60. But in this case, we would have 5 and 12 and 5 and 12. One of these does have to be negative, and that would be the 5. So negative 5 plus 12 gives me 7, and negative 5 times 12 gives me negative 60. So that would give us x minus 5 times x plus 12. Now the last step in the Kim trick is taking your leading coefficient and dividing each one of these numbers by that leading coefficient. Then you want to reduce it. So 5/3, you cannot reduce that. So if that's true, then the denominator number comes in front of that variable. So that would give me 3x, and the numerator number stays there. So our first factor would be 3x minus 5. And then the second one, 12 over 3, can be reduced, and so that reduces to 4. So your second factor is x plus 4. And these are the factors for that trinomial. So you can go ahead and practice that. Well, actually, let's do one more. Let's do one more example using the Kim trick. (3x squared minus 5x plus 5). So if you want to stop this video and see if you can try it by yourself first, and then you can start it up after you're done to see if you get the correct answer. So hopefully you got that, and let's see if we got the same thing. So I take my leading coefficient and multiply it by the last term. So that gives me x squared minus 5x plus 15. So two numbers when I multiply, I get 15. Same two numbers when I add, I get minus 8. So that would give me x minus 5 times x minus 3. So don't forget the last step in the Kim trick. We take that leading coefficient and divide each one of those by that number and reduce. So this one you cannot reduce, so that denominator comes in front of that first variable. So 3x minus 5, and this can be reduced to 1. So our factors would be 3x minus 5 times x minus 1. So hopefully you got the same thing as I did. Okay, let's move on. Our next method in factoring is looking at something called the difference of squares. So this looks like a squared minus b squared, and that equals, and it factors to a minus b times a plus b. So it might be helpful for you to write down some of your perfect squares so you can recognize when to use this factoring method. I would suggest you writing down maybe 1 squared all the way up to 10 squared just off to the side. When you're working out these problems, it might help you to recognize that we're looking at a difference of squares. Again, the word difference means minus. Squares means we have squares for the first term and for the last term. So let's go ahead and look at an example of this. So I have something like x squared minus 25. So I could recognize that I would use the method, the difference of squares, because number one, I have a minus right here. And also, the first and the last term are perfect squares. So this factors to x minus 5, because the square root of x squared is x, and the square root of 25 is 5. And then we would also multiply by the conjugate for the second factor. So these would be the factors using the difference of squares. Okay, let's look at one more. How about 3? Oh, excuse me. Let's not do that. Let's do this one. 9x squared minus 4y squared. So again, recognizing that 9 and 4 are perfect squares. So the square root of 9x squared would be 3x. And the square root of 4y squared would be 2y. And then multiplying by its conjugate, 3x plus 2y. And so these two would be the factors using the difference of squares method. Okay, let's take a look at some cubes. So the last method I want to talk about on factoring is the sum and the difference of cubes. So let's start with the sum first. So the sum of cubes. So just like I suggested with your difference of squares, if you would like to write down some perfect cubes, I would suggest from 1 to 10, and then that would help you recognize when you have a perfect cube. But let's talk about the formula first. So a cubed plus b cubed, again, sum means to add. So that factors to a plus b times a squared minus ab plus b squared. So that would be the formula. So using that formula, let's go ahead and take a look at an example. X cubed plus 64. So I can recognize we have the sum because of the plus, and I also know that these are perfect cubes. If you make that list, the 64 will just come out in your list. So you know that this is a perfect cube. So to figure out your a, you take the cube root of x cubed, which is x, and then you would figure out the cube root of 64, which is 4. So that's your a and that's your b. So fill out the rest of the formula. A squared would be x squared minus a times b, so that would be 4x, plus the formula plus 4 squared, b squared, and that would be 16. And so then that would give us the factors for this example of the sum of cubes. Let's do an example of the difference of cubes. So difference of cubes. So the only thing that's different with this one is we have the minus. Difference means minus. So we have a cubed minus b cubed. So that factors to a minus b times a squared plus ab plus b squared. Again, the list that you make for the difference, for your cubes will help you recognize this also. So let's go ahead and take a look at an example. So 27x cubed minus 125. So to figure out our a, we take the cube root of 27x cubed, which is 3x. And then you want to figure out the cube root of 125 for your b, and that would be 5. And then let's fill out the rest of the formula. So your a is 3x, so we square that. That would be 9x squared plus a times b. This is my a, this is my b. So 3x times 5 would give me 15x. Drop down the plus. And then b squared would be 5 squared, which is 25. And these would be the factors for that example using the difference of cubes. So I hope these examples are a good review for you to help you get through Unit 16.